right, our next quiz is going to deal with equilibrium, and it's a part that looks like this. This is out of our book, and this thing has three forces on it, one pushing down on the left, one pushing sideways on the right, and some kind of weight hanging down on the right. We don't know how big it is. And the book is asking us to find out how big is that force F. If this whole setup is in equilibrium and it's balanced like a teeter-totter, then how big is F? And here at the bottom of the slide, I've given you the answer that you should come up with if all goes well. So the first thing we're going to do is find out how much moment is caused by each force. And let's start with this 250-pound force on the left. Now, if we want to find out the moment, remember moment is force times distance. Here's the force, 250. The question is, how big is the distance? And remember that distance is from the pivot point perpendicular to the line of action. So here I've drawn a diagram. There's the force, there's the line of action, and there's the direction that would be perpendicular to that line of action. So that tells us that the distance from the pivot point perpendicular to the line of action has got to be that bottom base of the triangle. In other words, the side that is adjacent to the 20-degree angle. And we know that the hypotenuse is 10 feet. We're looking for the adjacent. So which trig function do we want? We want cosine. All right, but we're looking for adjacent, so we're going to rearrange the terms, multiply both sides by h. The adjacent will be h times cosine, or 10 times cosine 20. That will give us that distance from the pivot point perpendicular to the line of action. Now let's think about whether that is a positive or a negative moment. That force trying to swivel that arm. And it's making a circle, trying to make a circle that looks like that. So what is that? That is counterclockwise. It's not the way a clock turns, it's the opposite. So that's going to be a positive moment. Now let's look at this 100-pound force pushing on the right. And here I've drawn a triangle for this arm. And here is the line of action for our force going across the top. And he tells us this is a 45-degree angle. And I've written 45 degrees in here. He wrote 45 degrees down here. We can do that because these are, what do you call those, complementary angles. That angle plus that angle adds up to 90. That's why I could write 45 degrees in there. And that length of that bar is 14 feet. So moment equals force times distance from the pivot point perpendicular to the line of action. There's perpendicular to the line of action. So that means our distance is going to be along this vertical edge adjacent to the 45-degree angle. And so which of our trig functions uses adjacent and hypotenuse? Again, it's cosine. Cosine is adjacent over hypotenuse. And again, we're looking for adjacent, so we'll rearrange the terms. Hypotenuse times cosine gives us adjacent. What's the hypotenuse here? It's 14 feet. So 14 times cosine of 45, that will give us that distance, that vertical distance from the pivot point perpendicular to the line of action. And is this force causing positive or negative moment? Well, it's trying to rotate around point C like that. That's the way a clock turns, so that's clockwise, so that's a negative moment. All right, now let's look at force F. And this is the one we're trying to find. We don't know how big that weight is pulling on there. We do know that this is a 45-degree angle, and we do know that there's a 14-foot length along here. And we're trying to find the distance from the pivot point perpendicular to the line of action. And here's the line of action. There's where the perpendicular distance will be. So our distance will be along the horizontal base of this triangle. In other words, adjacent to the 45-degree angle. So again, adjacent and hypotenuse, we're going for cosine. Seems to be our theme here. And we're looking for adjacent, so we'll multiply both sides by h to rearrange the terms. So h is 14 feet. 14 times the cosine of 45, that gives us that distance. Okay, now is that hanging down force causing a positive or negative moment? Well, let's picture what direction it's trying to pivot. It's trying to go that way, and that's the way a clock turns. That's clockwise, so that's a negative moment. Now you can write a whole string of moments that add up to 0. Remember this tool in your toolbox. The sum of all moments equals 0 if this is in equilibrium. And I made a subscript C there because I want to say the sum of all moments around point C add up to 0. And each one of those moments is a force times distance. So sum of all moments around C. We've got, there's that 250-pound force, and there's that distance that you found. I hope you found 9.397. And we said that was a positive moment because it's counterclockwise. Now the next force, 100 pounds, and you found a distance, I hope, of 9.899 feet, and that's causing a clockwise moment, so that's a negative moment. And finally, F, we don't know how big F is, but we know its distance. Its distance is also 9.899, and that is also a negative moment because it's trying to spin clockwise. And what do those all add up to? The sum of all moments equals, ta-da, 0, because this is in equilibrium. So I've just written this string. Force times distance, force times distance, force times distance. Those all add up to 0. Now we're trying to find F. This is our original goal. And how do we get F by itself? Well, if we add the same thing to both sides will still be equal. So we'll add F times 989, F times 9.899 to both sides. Those two terms will cancel out, and we'll be left with this term, 250 times distance, minus this term, 100 times this distance, equals F times this distance. Okay, now how do we get F by itself? Well, we can do the same thing to both sides again. Divide both sides by 9.899 feet. These two will cancel out. We'll be left with this glop divided by that glop, and you'll punch that on your calculator, and that will tell you, hooray, how big is F. And we had the answer in the first slide there. What the heck was it? It was 137.322, I hope. So there you are. Let me know if you have questions with this thing.